Hello everybody, welcome to my channel. Today we have an amazing problem for you guys called single number. This is a very good one, so make sure you pay close attention to the problem statement, right? So it says, given a non-empty array of integer nums, right, every element appears twice except for one. Find that single number, okay? You must implement a solution with a linear runtime complexity and use only constant space. Wow. So very good problem statement, very concise, very simple. Easy to understand, right? So a non-empty array of numbers, and we need to return the number that only appears once, right? Because every other number appears twice, right? That's what they're saying here, okay? So the example is very straightforward. So you see we have two twos, only one, right? So the single number is one, right? In this example, you can see that we have two ones and also two twos, right? The only single number in there is four, right? So that's why we return four. And then we got one here and return one because that's the only number in there with no duplicates, right? So very simple, right? Yeah, it makes sense. So how do we go ahead and solve this problem, guys, right? Now, we normally like to start off with the most straightforward solution, like, without being clever, right? So I'm thinking easy way of doing this is to do a double for loop, right? Double for loop, right? So for each element, we search the remainder of the array for to see if there's any occurrence, right? Find all the occurrences of that number. And after enumerating through all those numbers, right? If the count is one, then we know that's the single number, right? If it's not one, then we know that's not the answer. Then we go on to the next one and keep doing doing this for every index, right? Now you can see this is an n-squared solution. It does, meet the constant space, right? But the is not linear time, right? It's n squared, guys, right? So it doesn't work. So we already know sup. When we have those n squared, we can introduce data structures, right, to help reduce the time complexity. Hash map will do the trick for this one. Just store the occurrences of each number, right, in a hash map. So we do a linear loop through the array, put all the occurrences in the array, right? And the hash map, right? And then do another loop through the hash map, and whichever number that has a count of one, right? We return that as the answer, right? It's not too bad. We have the linear runtime, right? Just two scans, right? But the space is we increase space, right? We have linear space as well, so it doesn't fit the constraint, guys, right? But those are good starts to good solutions to start off with, right? I'm thinking about my inverse setting, that will be good to start getting the problem solving skills, flowing, right? So how can we improve, guys, right? What else can we do to get that linear runtime and extra space? Okay, so to solve this, you'll need to sort of know some stuff, right? So let's go to my drawing board, right? We're going to be talking about this XOR thing, right? So using bitwise operation can help us to efficiently solve this problem, and I'm going to show you guys how it's helpful. Okay, so XOR is going to be very helpful for this problem, guys, right? Because of the different properties that it has, guys, right? So one of the properties that that's very good about XOR is that and so we'll start off with this first, right? So say you have a XOR A, right? That equals to 0, right? So before we even get into that, right, let's just go through the truth table for the XOR operation, guys, right? So 0 and 0, that is 0, right? It's an exclusive OR, right? And then 0, 1 is 1, right? Because one of them is true, right? And this one as well, only one of them is true, right? And 1, 1, since they're both true, that's 0, guys, right? So there can only be one that's true for it to be true, guys, right? So this is how the truth table works for an XOR right, operation, right? So you can see you have two zeros, 0, right? 0, 1, yes. 1, 0, yes, right? So you can see that yeah, so this is what this had, right? A XOR A is 0, right? And also, so let's quickly do an example. Let's say you have a number 5 and 3, right? And we want to XOR them, right? And see how they look like. Okay, so you see it will go 1, 1. Oh, so truth table, right? We know that it's 0, right? 0, 1, 0 is 1. 1, 0, 1 again, right? And then 0, right? So this is how the XOR operation would work, guys, right? So let's say, to show you guys the a XOR a, right, equals 0, guys, right? Say, we want to let's say 5, right? We got 5, let's say 5 is 0, right? XOR itself, right? Okay. To show you guys how the whole thing is going to work. Okay. So we do 1, 1. We know that's a 0, right? 0, 0 is a 0 again. 1 XOR 1, 0, right? And then this one 0, right? So I'm showing you guys this to show you guys, how this is going to be helpful, right? It's going to allow us to, so you know that if a number contains a duplicate, right, in the array, right, us XORing it with, they cancel each other pretty much, right, turning into zeros, guys, right? That's why this is going to come into play, the XOR thing, right? Because, anything XOR with itself, right, it's 0, right? Okay. And also anything, that's XOR with 0, right? It's the thing itself, right? Right, it's itself, guys, right? So those are just properties that you need to know. So a XOR, any element XOR itself equals 0, right? And I showed you guys why that's the case, guys, right? So make sure that's very clear, okay? And then one other thing that I want to, before we go to a walkthrough and go any further, right? One more thing I want to bring up is the cumulative property as well, right? So the ordering doesn't matter, right? So a XOR b is the same thing as b XOR a, right? Okay, is the same thing, pretty much the same thing, right? Your ordering doesn't matter, right? It's the same result that it would yield, right? And just like also the associated property as well, right? The grouping doesn't matter, right? The grouping doesn't matter. So you could have a XOR b, right? It's supposed to be a parentheses, so a XOR b, XOR c, right? It's the same thing as having say you have b XOR c XOR a, right? It's the same thing, guys, right? The grouping does not matter, right? So two main things, right? The ordering does not matter. A XOR b is the same as b XOR a, right? And this a XOR b XOR c is the same thing as this one, right? So those are two things to keep in mind, right? So with that in mind, we know that any element XOR itself equals 0, right? We know that, that's the case, and we've proven that. So we can straight up go through the whole array, right? XORing everything together, right? And any number that has a duplicate, right, will cancel itself out because of the property of a XOR itself, right, equals to 0, right? And by the end of the iteration of the whole array, right, we'll be ending up with the single number that did not have a duplicate, right, to cancel itself out, right? So it will be the only person standing, guys, right? So the only man standing, guys. So that's why it's so efficient, right? So it's a linear scan through the array, XORing everything together, and by the end of the iteration, we have a single number, and that variable can just return that, right? So you can see the XOR thing is a very efficient way of solving this problem. So let's just go through an example, right? We'll do 4 XOR with 1, right? XOR with 2, XOR with 1, XOR 2, right? And we see that, this one cancels itself out, right? Boom, because, right? And then we got, remember the associative property, right? The ordering, the grouping doesn't matter, right? So we just, we might as well just have put in like 1 right next to the 1, right? That's how, the properties make sure that, we're good with that. So we do 4 XOR 1, and we do this cancel 1 XOR 1, right, to cancel itself out, okay? And then we get this 2 that cancels out this 2, right? And then by end of the iteration, we have 4, guys, right? So that's how it would cancel themselves out, guys, right? And then we end up with 4. So the code will be very simple. Let's quickly go ahead and code that up, guys. So what we're going to do is to have a number, right? Let's go ahead. Number equals to 0 initially, right? And then we're going to do a linear loop through the array. Right? What we're going to do is to do, let's call it single number. Single num. And we're going to do everything XORing num, right? So every number is going to be XORing with this number, right? And then by the end of iteration, right, all duplicates will cancel each other out. Then we're going to be returning single num, guys, right? Just like that. So let's press run code, see if we pass these small test cases. Let's press submit. All right, guys, we're about to pass all these test cases, guys, right? So we came up with the most optimal solution, right? We started off from the brute force and work our way up to the optimal one. So hopefully you guys were able to understand the walkthrough that I did and everything, right? So if you guys enjoyed this video, let me know that in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.